All right, folks. Well, this will be a relatively short one. Last time around, we touched on the idea of variables not having a fixed data type. And therefore, before we use a variable, we actually have to check and make sure that the value in it is of the type that we're expecting. So this causes all sorts of issues. You never know, as you know, if you're writing a function, you don't actually know that somebody's going to pass the parameter types that you're expecting. So you have to check the types of the parameters that you're given. You know, if you're working with variables, you have to check that the variable has got an appropriate data type before you try and do something with it. So we're going to wind up doing a lot of type checking as part of the development of our programs in Lisp. Again, just something to get used to with dynamic data types. So today we'll go through and play with a bunch of the type checking functions. All right. Again, you can pass any kind of a value to a function. We have to be able to figure out what kind of data was actually passed. You can put any kind of data in a variable. You have to check what kind of data it's got in it right now before you use it. And again, this is done with function calls. Right? Everything in Lisp is a function call. So for all of the built-in data types, there is an existing function that can check if something is of that type. And they'll return true if it is and false if it isn't, so t or nil. Pretty much the convention is that these type checking functions end in a p. So you'd have integer p to check if something's an integer, float p to check if it's a float, list p to check if it's a list, function p to check if it's a function, etc., etc., etc. So there's a huge slew of different data types that are supported and a huge slew of these different built-in type checking functions. And then there's also, actually, for some of the other more complex types, there are ways to automatically generate a type checking function as well, but we'll get into that later on. So maybe we'll just have a quick play with a little bit in terms of some of those functions and Lisp, just to see how things go here. So again, the idea is, say we type up or fire up our interpreter, and I want to see is let's see if, I can't spell at all. Let's see if 10 is an integer. Yes. Let's see if 10.5 is an integer. No. Let's see if 10 is a float. Why not? No. Let's see if 10.5 is a float. Yeah. So you've got a whole slew of different things you can check if something is a number or not. So I can say, is 10 a number? And same sort of idea. And of course, number is going to work for all sorts of different things. 10.5. Can't remember if I can get away with something like 10 over 3 or 10 over 4 as syntax for a rational. Will it allow me to do that? Yes, it will. So this is basically treating rational numbers as well. So you can express things using the numerator / denominator to denote a rational. So I believe there's a rational p that will check if, say, 10/5 is a rational. Yeah. So again, lots of different functions in there. I can check if something's a string, blah, blah, blah. Right? And again, it's going to come back with true. So lots of different built-in type checking functions. All right. So again, this is going to become part of life. Just when you're writing Lisp programs, you're going to wind up checking the value that's in something before you wind up just assuming that it's got the right data type. Again, you're typically going to wind up doing this as one of the first parts of every function call. Check your parameters. Every time you read a value from the user, you're going to be checking what type it is. Anytime you're writing scripts that use command line arguments, you're going to be checking to make sure that the arguments are the types you're expecting. There are a few other type checking functions. So type of will give you back a symbol telling you what data type something has. So it'll give back, for instance, float or integer or string. Type case we'll play with a little later on, that essentially acts almost like a switch statement or a case statement, where you ask essentially, what's the data type of a particular variable or a particular expression, and it's going to, you can then give it a list of data types, and it'll go through and pick the right one. You can check if something matches a particular type with type P. So this is asking, does X have the particular type that you're interested in? So again, let's see if we can play with a few of these just briefly. So let's say, let's ask, what's the type of 105.3? And so it tells me it's a long float. What's the type of, again, 10 over 3. Right, again, so it's going to go through and give us the data types. What's the type of 10? Fixed number. So I can go through and check if something has a particular type using things like type P, 10, and some type. So does this have type integer? Yes. Type P10 fixed number. Yes. Right, so we can play with a variety of different type checking techniques. And again, later on, we'll get into some user-defined types and ways to devise type checking functions for those user-defined types. But we'll come back and play with that later on. All right. Again, type checking is something that you're going to be doing a lot of in the very near future.